Hi, well, I'm Stephen Neshaba, and I'm here to tell you a little bit about the differences between catalysts versus reaction intermediates. And to do that, I got a couple of examples for you, but let me give you just some general concepts here. So both of them, a catalyst and a reaction intermediate, neither one of them appears in the net stoichiometry of a reaction. But a catalyst is supplied. It's first it's consumed and then it's regenerated. So that's why it doesn't appear in the net reaction. Reaction intermediate is different. It is generated by some step in the reaction and then later on consumed, and that's why it doesn't appear in the net stoichiometry. So we'll do a couple of examples. One of them is the decomposition of H2O2, which I've drawn a mechanism, and it's a two-step mechanism. And here it goes. H2O2 combines with I minus, iodide, to produce water, and this IO minus. And then the IO minus combines with another H2O2 to regenerate the I minus and make another H2O2, H2O and an oxygen. So if you think about our definitions there, you can see that I minus is supplied at the beginning of this reaction, so it's a catalyst. It's consumed in that first step, okay? And then it really is regenerated because look at here, it was reproduced right there. So we would say, if I just want to put a circle around catalyst, I minus is clearly a catalyst. And, well, this reaction also does have a reaction intermediate, and it must be the IO minus, because look, IO minus is generated by the first step, but then it's consumed in the second step. So I would put a little box around that one to indicate that it's a reaction intermediate. Now, the net reaction, of course, when we add these all up, I canceled out the IO minuses and canceled out the I minuses, so that the net reaction is two H2O2s making two waters and an oxygen molecule. Fine. How about this second example? Here we have NO combining with N2O to make N2 and NO2, and then two NO2s make as NO again and oxygen. So if you want to kind of think about this, maybe pause and see if you can identify any reaction intermediates or catalysts in this. Okay, first let's just tackle which one might be a catalyst. And so I'm seeing NO here is consumed in the first step, and then actually two NOs are generated. So NO has got to be a catalyst for that reaction, at least one of them, okay, because it was consumed and then regenerated. In other words, the reaction can't even get started without it. And how about a reaction intermediate? Well, I'm looking at an NO2 which is generated here, okay, and then consumed right there. So the NO2 must be a reaction intermediate. And let's just look at the net stoichiometry here. So I have one NO here and two of them there, so there's a net NO that appears in the product. I have an NO2 here and two NO2s here. That means there's an NO2 that has to appear in the reactants. So what we conclude is NO is not only a catalyst for this reaction, it's also a product. And NO2 is not just a reaction intermediate, but it's also one of the reactants. So, okay.